Hello viewers, I'm an engineer Azamat. Welcome back to my channel Electrical Engineering and Tech Skills with iOS. So today we will learn how to install 300-watt system solar system designing. So I will calculate all the requirement for 300-watt solar plate design for your home. If you are designed for a small home, if you will design for a large home, then we will also calculate by using these calculations. So the formulas will be same, just the values will be different. For example, the size of a battery would be different, or the size of the power would be uh, depend upon the size of your home and your appliances, your home appliances. So let's start. So 300 watts solar system designing. So first of all, we will consider a small house. So this is your small house. uh, this is your house, for example. So we are gonna design a system for this small house, just like a cottage small house. So we can also design for large house as well. So now, for example, now we in our house there will be electrical appliances. For example, two fans. One fan is 80 watt. You all know, I think. If you are an engineer, so you should know these basic things. So one fan consists of 80 watt. So here are two fans, 2 multiplied by 80 watt. Then this will be, I think, 2 multiplied by 16, so 160 watt. And energy saver two energy saver bulbs, and each would be 25 watt. If they are 2 multiplied by 2 is equal to then 50 watt. One tube light, so like this tube, its shape is like this tube light. One tube light is equal to 40 watt. So I will take 40 watt for this house because the designing is 300 watt. So that's why you can also take the 36 watt. So now here I am taking 40 watt and one LED TV. So it's now you have to find if you will design the solar system, then first of all you will find these three parameters. First of all, UPS or inverter. UPS or inverter. First of all, you have to find this one. And the second, the important thing is battery size or battery ampere hour is equal to what. And third, solar plates. So solar plates. So now first of all we will calculate for this UPS. So the UPS equals to, I will recommend that you should buy 100 to 1000 watt automatic UPS, because it's then and then after calculate we will calculate a power. As we all know, that voltage multiplied by current. So here suppose our battery is 12 volt, so we are designing for 300 watt. So 300 equals to 12 multiplied by I. Then we could easily find out current from here. Current equals to 300 divided by 12. So the current will be equal to 25 ampere. Don't forget to mention its unit. It is too much important. System International Unit, SI unit. So we will solve this step by step, because these are too much important while installing the solar system. So I have found out the first thing, that is UPS selection. So you should buy automatic UPS or inverter. You can extend your house. If you can use more appliances at home, then this would be good. Otherwise you can purchase 500 watt UPS or inverter. It is good, but if you will extend your house appliances, if you will install more appliances in your house, then 100 watt UPS or inverter would be great. Yeah, it is flexible for usage. So the second important thing is battery size. So always remember that its SI unit is ampere hour. You should keep in mind ampere hour is its SI unit, System International Unit. So we will find this one. So battery size, its formula is equal to watt multiplied by R, then divided by volt. So if I will further explain this thing, this is W is total load. For example, total load of your home's appliances. For example, these are 2 bulbs, these are 2 fans, like this fans, and this is tube light. All appliances and load, total load, multiply by backup time. It is always in hours. Then divided by this is V battery. Battery voltage. This is battery voltage. So now I will put values into this. So total load will be 300 watt, because we are designing 300 watt, multiply by backup time in hours. For example, if our light goes for 10 hours, or if you use an electricity for 10 hours, for example, you can use it for 6 hours, 5 hours, it depends upon you. So I will take here 10 hours. For example, my backup timing is 10 hours. So I assume this. You can assume 8 hours, 5 hours, it depends upon you. So battery voltage is here 12 volt. If I will calculate this, then I think it will be 250 ampere hour. So I have said before that don't forget to mention its unit. The battery size unit is ampere hour. So let's move further. The next thing is if I will reduce my backup time. If I will reduce my backup time, then for example here 300 multiplied by, first of all my backup time was 10 hours. Now I will take backup time 5 hours divided by 12. So it will be equals to 125 ampere hours. So now size of battery will be reduced here. Size of battery will be reduced. So we have to analyze this thing, so that's why we have calculated this. If we will take our backup time less, then the size of battery would definitely will be reduced. For example here if we will take our backup time more 10 hours, then our battery size will be more. If we will take it less, then our battery size would be less. So these all are the analysis. So being an engineer, you should be good in analysis. So your analysis skills should be good. You are good in analysis skills. So now let's move on. So now I will give a suggestion to you guys. You should purchase tabular battery. You should purchase tabular battery. Tabular battery. Tabular battery. Because why you will use tabular battery? Why you will use tabular battery? Why you will use tabular battery? So the answer is too much simple, not a rocket science. Because the tabular battery is specially designed for the solar systems. So this is specially designed for the solar systems. So that's why you should buy a tabular battery. You can buy Osaka battery, and there are many other batteries. So I will recommend that. This is a cost. Its cost is greater, but you should I think you should buy this one, because quality matters rather than quantity. So if you will buy this one, so its lifetime will be more, so its efficiency is also good. So its backup timing is also good. So that's why you should buy this one. Now I will calculate the battery charging current. Battery charging current. So its formula is equal to 1/10 of that rated battery rating current. 1/10 of battery rating current. So for example, here 1/10 means 1 divided by 10 multiply by half means multiply by. I have said this many times. This is a basic question, so you should also keep in mind. Half is used for multiplication in a basic mathematics. So being an engineer, you should be good at basic mathematics. So I am also making basic mathematics videos, so in order to clear your concept, so I will make a lot of videos in future as well. So the rating time, for example, I have calculated 2 times for large size and for small size. I will calculate both of them. Here first of all 250 uh, I will take, then it is equal to 25 ampere. If I will take for 125 ampere or so, it will be equals to, so your size will be reduced. 25 ampere, now it's 12.5 ampere. So let's move further. So now the final thing we will find out is solar plates. Solar plates. So this is the final calculation. This is a lengthy one. So first of all, we will add up the battery charging current plus load current. So battery charging current, for example, I will take 25 ampere for the first one, plus 25 ampere was the load current. We have find out at the very first step, so go there and watch that. So it would be equal to 50 ampere. If I will take for the next one is 12.5 ampere, that we have find 12.5 ampere plus 25 ampere is equals to 37.5 ampere. So now if I will look at the first one, so our total solar current is equal to 50 ampere. So here I have taken for the above this first one case. So I will recommend you that you should keep a pen and a copy with you. So pause a video and write this on your notebook. It would be helpful. So I have find out this. So now for example, this is a solar plate. So as we all know that the famous solar plate size is 150 watt. 150 watt for 12 volt. So we have designed our system for 12 volt, so that's why we will take 150 watt solar panel. So the power will also be same. The power's formula is P is equal to V multiplied by I. So for example, we will take our current, the total solar current was 50. So here we will find this voltage. So VOC, open circuit voltage for solar system for 150 watt solar plates is ranges from 18 volt to 21 volt. So when we will connect this with our circuit, then the voltage reduces from these threshold voltages. So that's why we will assume less voltages as from standard voltages. So for example, let's suppose I will take 16 volt. You could take 15 volt, 18 volt, 14 volt. It depends upon you. So here I am taking 16 volt. So I will take 16 volt for my designing. So solar plates power will be equals to Vi. V is here, I have taken 16 volt multiplied by our current is 50 ampere. So now we will so total plates power is equal to 16 multiplied by 50 means 800 watt. So this is 800 watt. So we have designed this for 150 watt. So we will divide it in order to the requirement for the solar plates. So if we will divide this total plates power 800 divided by 150, so we have designed for 150, so that's why we are dividing it. So 800 divided by 150, so the result will be 5.33. so approximately we will take 5 solar plates. So we will take 5 solar plates to design this for 300 watt solar system. So we will connect 5 solar plates for 300 watt solar system for our small house. So thank you so much, viewers. If you are an engineer, so don't forget to tap on the subscribe button. You will find out here an interesting videos. Thank you so much once again. This quality is good, so I would